All right, let's take a look at this example. Here we're asked to solve triangle ABC and round our answers to one decimal place. The information that we're given is that the length of side A is equal to 27, the length of side C is equal to 26, and the measurement of angle B is 67.8 degrees. So this particular situation, we have side, angle, side given to us. In other words, we're given the length of two sides and the angle between those two sides. Anytime we're given side, angle, side information, we have to use the law of cosines to solve the triangle. Anytime we're given side, angle, side information, the first thing that we want to do is find the length of the side opposite the angle that's given. So here we're given the measurement of angle B, so we want to start by finding the length of side B. And to do that, we'll use b squared equals a squared plus c squared minus 2a, that should be c, not 2ab. Pardon my mistake. So let's try that again. So to find the length of side B, we'll use the formula b squared equals a squared plus c squared minus 2ac times cosine b. Plugging in all of our given information gives us 27 squared plus 26 squared minus 2 times 27 times 26 times the cosine of 67.8 degrees. Now it's just calculator work. 27 squared plus 26 squared gives us 1405. And then when we simplify minus 2 times 27 times 26, we get minus 1404, and that's still multiplied by the cosine of 67.8 degrees. And this gives us 874.5115353. Now at this point, we do not want to round this number. I always try to stay as exact as I possibly can, and my calculator took this out to 7 decimal places, so I wrote down all 7 decimal places for the value of b squared. One other thing to remember is that when you're plugging this value into your calculator, you want to make sure that you're in degree mode, not radian mode, because here we're looking for the cosine of 67.8 degrees. Now let's find the square root of that 874.5115353 to find the length of side B. So we find the length of side B to be equal to 29.5721412. Notice that I have not rounded this value yet. I will before we get our final answers, but I wrote down the entire value of the length of side B because I'm going to want to use that entire value in a subsequent calculation. That being said, when we round the length of side B per our instructions to 1 decimal place, we're going to get the length of side B is approximately 29.6 units. Now at this point, we need to find the measure of angle A and the measure of angle C. We can use either the law of sines or the law of cosines to do this. However, using either the law of sines or the law of cosines, we will have to use a not so exact value. Here's what I mean when I say that. I'm going to have to use this value in the law of sines or the law of cosines. And even though this is correct to 7 decimal places, it's still not absolutely correct. So we're just going to do the best we can. And I'm going to plug that 7 decimal place number into the law of sines to see if we can find the measure of angle A. Using the law of sines, we'll get the sine of angle B, which is 67.8 degrees, over the length of side B is equal to the sine of A over 27. Now let's solve this for angle A. Cross multiplying and solving for sine of angle A gives us 27 times the sine of 67.8 degrees divided by 29.5721412. Now let's use the inverse sine function to find the measurement of angle A. Doing a little bit of calculator work then shows us that the measurement of angle A when rounded to 1 decimal place is about 57.7 degrees. Now we can use the information that we have to find the measurement of the last piece of information that we need, which is the measurement of angle C. So to find the measurement of angle C, I'll start with 180 degrees, subtract 67.8 from that, and then subtract 57.7 from that, and that will leave us with the measurement of angle C. And with that, we found that the measurement of angle C is about 54.5 degrees.